Each year, the Royal Observatory Greenwich hosts an Astronomy Photographer of the Year competition. And to celebrate the craft and skill of the entrants, we're going to be taking a closer look at subjects within astrophotography. Today, let's talk about the colours of stars. When glancing at the night sky, people sometimes assume that the stars all produce silvery white lights. Perhaps if you ask them about it, they'll tell you that they think the sun is yellow, but they don't really think about that contradiction. In truth, stars take on a variety of colours, depending on the temperature of the star. Stars emit light across a wide range of different colours or wavelengths of light, including some that we can't see with the naked eye. The hotter a star is, or the higher its effective temperature, the more light will be produced towards the bluer end of the rainbow spectrum, and the cooler the star, the more light will be concentrated towards the redder ends. If we concentrate only on stars in the main sequence stage of their lives, and the types of light our eyes can perceive, there are a few ways to classify what we're looking at. The most common method is called the Morgan-Keenan classification system. This method assigns stars a letter according to their temperature, so the coolest stars are M-type and the hottest are O-type. The bluish stars in the well-known Pleiades cluster, for example, are B-type stars. Not the hottest, but considerably hotter than our own Sun, a G-type star. Although these letters can seem a little confusing, this classification method works out well, as these categories also fit for the different masses and luminosities of stars, as well as their colours and temperatures. Smaller stars may be roughly half the radius of our Sun, 3,000 degrees cooler, and less than 10% of the mass and luminosity, while larger ones may typically be more than 6 times the radius of the Sun, 25,000 degrees hotter, more than 16 times more massive, and 30,000 times more luminous. Of course, this is just one way of classifying stars. Modern astronomy quite heavily uses the brightness differences in agreed colour bands, what we call colour indices. In fact, the old colour classification doesn't really represent what your own eye would see. Not only is it based on the peak of a star's emission, it doesn't really account for how a human eye behaves. You'll notice that there are no green stars or indigo ones for that matter. And perception certainly matters, particularly when we are observing through the distorting effects of the Earth's atmosphere. Cells of air with different temperatures, compositions, and densities not only cause the stars to scintillate or twinkle, but also to change colour as the starlight is scattered. Here we see light from the bright A-type star Sirius, as collected in frames by the astrophotographer and assembled into this colourful collage. It's clear to see that the appearance of the star does not remain the same. You can even see that sometimes it looks a little greenish in colour, despite not being a green star. Human eyes perceive colour quite poorly in low light conditions. Reds are easier to see, but blues are trickier. One of the wonderful things about astrophotography is that the images created can reveal some of the variety and splendour of the night sky, which was there all along, but that we could not perceive without a little help.